Hello, everybody, and welcome to part 2 of the Performance Testing Series. Today's topic is Setup and Execution for Finance and Operations Apps. My name is David, and I'll be your moderator today. We are broadcasting this session through Teams live events, and the audio can be heard through your device speakers. This session is being recorded on behalf of the Microsoft Corporation. When you join this event, your name, email address, and/or phone number may be viewable by other session participants in the attendee list. By joining, you're agreeing to this experience. The recording will be available on the TechTalk's Community Dynamics page within 5 business days. If you have questions for the presenters or need support, please use the Q&A panel located on the right side of your screen. Our presenters will be responding to your questions during today's session. Thank you for your patience during these announcements. Presenting for us today from Microsoft, we have Stephen Koppens, Senior R&D Solution Architect, and Kenny Saelen, Senior R&D Solution Architect. Stephen, over to you.
Thank you, David. Before getting into the depths of this tech talk, I'd like to quickly remind everyone of the Dynamics 365 implementation guide. Since everyone watching this is interested in performance, special attention should be given to Chapter 17, Performance Solution Beyond Infrastructure. The purpose of this tech talk is to discuss how customers and partners can do performance testing. We'll also look at some simple scenarios where PerfSDK can be leveraged to perform the testing. In a later tech talk, our team will look at how the results can be analyzed and optimized. We will start with a quick discussion on appropriate tooling before moving on to discuss some general considerations for performance testing, such as system configurations you should set up prior to performance testing and data composition, as they can have a significant impact on the results. After we have touched on these points, we will look more closely at how customers can run manual performance tests. This is important because not having access to tools should not prevent customers and partners from running performance tests. We'll next cover how customers and partners can automate performance testing using PerfSDK. There are other tools that can be used, however, we'll focus on PerfSDK. During this section, we will cover 2 scenarios in detail and show how we leverage different techniques to pass in parameters and the changes we made to the multi-user PerfSDK C# code to support these scenarios. We'll close out by sharing some best practices and a list of resources. Let's begin with the overview. Before getting into today's topics, let's quickly review what was covered in the previous tech talk on performance. We looked at why performance testing is important, as well as how planning for it is critical to a successful outcome. We also covered how to identify key business scenarios, as well as documenting performance goals and objectives for those specific scenarios. This led to a list of prerequisites that customers should prepare, as well as a list of topics that should be covered in a typical performance testing strategy document. So let's start by talking about tooling. There are a lot of tools available for testing Dynamics 365. However, not all of them are appropriate for performance testing, nor is there one tool that is appropriate for all performance testing scenarios. As such, it may be necessary to consider different tools when considering different scenarios. If we take RSAT, it runs the test in the context of a single user, so it doesn't scale for multi-user performance testing. There are manual testing approaches, which we will discuss in more detail. These can be helpful in some scenarios, however, they focus mostly on UI-based scenarios, and so other tools should be considered for integration and batch workloads. When considering multi-user performance testing, focusing on user concurrency, there are several tools available, such as Stress Stimulus and PerfSDK. We will demonstrate how PerfSDK can be leveraged within this tech talk. Other scenarios to consider include integrations, either via OData or other technologies, or more file-based integrations. In these scenarios, you should consider either web-based testing tools such as JMeter or the data management framework, respectively. It is important to ensure that the environment is configured prior to starting any performance test. These configurations should be part of your runbook so that prior to each performance test, you can ensure that the environment is configured as per previous runs, thus reducing the risk that performance bottlenecks are caused due to incorrect configurations. Also, if configuration changes are made, they can be tracked to validate their impact to performance. This does not represent a comprehensive list, and we won't spend too much time on the individual points as they've been covered and understood by now. So I'll just highlight that if you are using preview features such as priority-based scheduling, you should ensure it is part of your runbook and configured. There are also some items that require advanced preparation, for example, security roles. Having these in place when running performance tests will give additional confidence in the overall performance of the system, specifically if record-level security is being used. Data is critical for a successful performance test, and ensuring that you can test on data that is as close to production as possible and repeatable is important. As mentioned, data composition is hugely important for a successful performance test. Focusing only on the throughput without taking the time to review the data could lead to results you may not get in production. Therefore, it is important to collect information on the data that is being processed, the configuration of the system, as well as the required throughput. It is important to test with realistic data and with realistic data volumes and configurations. For example, if a process is tested without serialized numbers, it might perform extremely well. However, if serialized numbers are required in production, the same process may suffer from performance degradation. Another example is using too small a subset of data in a report. This may result in the report being generated very quickly. However, once again, against actual data volumes, it may perform poorly. Such performance issues could be identified and resolved prior to go live if the configuration was reflective of production data and using realistic datasets. Performance of specific business processes can be impacted by the data that is used. We have had experiences where customers have focused on the throughput but not the data, and this has caused performance issues. For example, one customer was processing thousands of pick, pack, and dispatch orders. They had a broad number of items being used and the appropriate number of users simulating the process. However, they were only using one warehouse, when in the real world, the same number of orders would have been distributed across multiple warehouses. The result was that the contention caused by the single warehouse caused a performance issue. Once additional warehouses were added, the team was able to focus on other areas to optimize, and after additional rounds of optimization and testing, the customer was able to go live with confidence. Another scenario that we've witnessed is the use of only one or two items to create and process orders. There are some key tables that are used during the processing of inventory. For example, InventSum and InventSum Delta Dim. Microsoft has put a lot of effort into optimizing all queries that hit these tables. However, we've witnessed a performance test that was only using one or two items. In that scenario where the configuration was not representative of real-world data, these tables became the bottleneck. Once again, after the test was corrected to use real-world number of items, the team was able to focus on other areas to optimize, and after additional rounds of optimization and testing, the customer was able to go live with confidence. There are other examples, but hey, hopefully you've got the idea of why data composition is important as it relates to specific processes. It is also important to consider how the data will be randomized to reduce false positives. These are more evident when the data set being used is too small. For example, using the same customer for every test can reduce the number of calls to the database due to caching. In our PerfSDK examples, we'll be looking at two different ways that the data composition for the tests can be parameterized, specifically using Excel and SQL. These are not the only ways to store and retrieve data for a test. However, they're a good starting point. Before getting into the details on automating performance tests, we wanted to share approaches to performing manual performance tests. Performance testing is critical for a customer to be able to go live with confidence. However, not all customers want to invest in building out automated performance testing tools and scripts. For these customers, they should conduct manual performance tests. Whether tests are going to be run manually or automatically, the process of identifying the core scenarios is the same. This has been discussed in more detail in the previous TechTalk. Once each of the scenarios has been identified, it is necessary to determine the best way to simulate load and how to be able to rerun tests with minimal effort on creating or recreating test data. For example, using point-in-time restore between tests so that you can leverage the same test data. When looking at options for manual interactive performance testing, you need to consider the number of people that are required to represent the number of users in the real-world scenarios. Companies will not always be able to have all the end users signed in and using the system for an hour over multiple iterations of performance testing. However, having only a handful of people processing transactions, in most cases, will not reflect an accurate day-in-the-life scenario. There needs to be the right mix of both users and transactional volume. One factor to consider is a smaller tier for testing on. Using a smaller tier, for example, a tier 2 or 3, would help identify bottlenecks that might be less obvious on a tier 5 machine with a smaller volume of users. I would like to emphasize that as soon as a scenario has been identified as critical for a performance requirement, its performance should be tested along with the functionality. By conducting performance tests for individual scenarios early on, you greatly reduce the risk to the project. Customers should have the batch servers as well as batch jobs configured as they are expected to be once the customer is live. Batch jobs should first be tested in isolation with the expected volume of transactions to ensure that no individual batch job is causing a performance problem. It is common that some batch jobs we run after hours and need to complete in a specific time frame. Testing these in isolation provides confidence to the customer that the system will handle their workload. For example, if you're using DMF for importing a large daily file, the sooner that can be tested and optimized, the sooner you decrease the risk to the project, even if you start performance testing on a tier 2 or 3 environment. Using the batch job configuration, a customer can identify which batch jobs need to be run while performing their day-in-the-life performance test. These should then be run with the appropriate volume of transactions during day-in-the-life performance testing to ensure no performance issues occur. Integration depends upon the pattern and tools that are being used. In some scenarios, we have seen customers collect messages from their legacy system and pass those through to the sandbox environment so that they can simulate real-world integrations while minimizing the user effort to trigger these. Careful thought and preparation is needed to plan out the best way to performance test integrations. Customers and partners should take the same approaches with batch jobs. That is, identify the critical workloads, test them in isolation with the appropriate volume of transactions, and then incorporate these into the interactive day-in-the-life test cycle. Reporting and analytics is often overlooked in performance testing. However, if a report takes a long time to generate, it can impact a business as much as any other scenario. Therefore, if users are expected to generate reports during the day-to-day business, and delays in generating those reports or printing them to a printer would impact the user's ability to continue with their activities, they should be incorporated into the test scenarios. Data migration should not be overlooked, and while it may not be applicable to incorporate data migration into a performance day-in-the-life test, it is critical to test and optimize data migration so that a customer knows how long their cutover window needs to be. It is never too early to start performance testing isolated scenarios. The focus should always be on performance, and users should be asked to capture information whenever any process is slow, irrespective of when. For example, if a process is slow in a conference room pilot, this information should be collected and shared with the team so that they can investigate. Finally, once the isolation tests have been completed and optimized, it is necessary to bring it all together in the day-in-the-life scenario and run all of the scenarios at the same time. Before running your performance tests, you'll need to prepare. This will involve ensuring you have identified the key scenarios, the appropriate volume of transactions and users, as well as the appropriate sandbox to use. The earlier you can start performance testing, the sooner you are able to identify and resolve issues. Thus, customers and partners can start running their performance tests on environments that aren't Tier 5. This is very applicable when looking at testing individual scenarios. For further information on sandbox tiers, you can see our previous TechTalk on environments. Whether manual or automated, it is important to have identified the required performance for a system. However, an important differentiator with manual testing is the granularity of the required results. This ties into the discussion on scripts, measurements, and reporting requirements. When identifying a scenario, for example, creating a sales order, a customer may say something like, "Today we have 10 users who create 100 sales orders in an hour peak volume." This makes for a simple performance requirement, and if tested using automated capabilities, the performance of the various steps and components of that test is captured by the tooling, as we'll see later. However, when performing manual testing, if the overall process is slow, unless the performance of the individual steps is captured, it is difficult to pinpoint any bottleneck. So it is important that scripts are provided to users so that they can perform the process in the same manner as they are expected to once live. The script should also be used to identify the specific parts of the process that should be measured. If we take the sales order creation process as an example, some of the steps that may be identified and measured include creating the sales order, adding a line, saving the order, and confirming the order. Regarding measurements, the team need to understand how to measure and record the times for individual components of the process. Several customers have used a stopwatch and then populated an Excel spreadsheet with the results. It is important that all measurements are captured and recorded, not just those for bad performance. This information can be plotted against other results to track trends and see if any spikes were common across processes or specific to just one. As manual performance testing requires more people than just the subject matter experts, it is necessary to train the users. Training typically happens around UAT. However, this will need to be brought forward so that more users know how to perform their tasks and can participate in the performance testing. It is also necessary to have all the security roles set up and configured and assigned to the users. Fixing on a time frame is important. Each organization has different processes, and some might extend over a longer period of time and need to be captured. Once a time frame is agreed upon, the decision can be made if the first 5 minutes or so will be ignored to get the users to start 5 minutes earlier. This additional time can be seen as warm-up time for users as they get themselves comfortable and start working on the scripts. If the test is going to happen after a deployment or restart, it will be necessary to warm up the environment before starting the performance tests. It is necessary to have configured and set up the batch jobs and integrations that are going to be considered during the day in the life performance test. Of course, data is critical, so ensure this has been prepared and is ready. This will need to be aligned with the data migration workstream. Sometimes overlooked is the final reporting requirements. Collecting the data is great, but it is necessary to present this information to the appropriate teams. Ensuring you know what the reporting requirements are can help verify that all the necessary information is being collected. While there are numerous reporting templates that are available, it is generally seen that the reports will include timings for various business processes, as well as information from the database query store, and overall system monitoring from LCS. It is recommended that before beginning the performance test, time is spent on defining and agreeing on the final report template and understanding what information needs to be collected, as some of the information may not be available at a later date. Also, conducting a manual performance test requires resources, and it would not be beneficial to complete the testing only to discover that you had failed to collect information that was important for the report and further analysis. There are numerous tools and features that can be leveraged to collect and analyze performance. The team is preparing a TechTalk that is dedicated to analyzing performance. Therefore, I just want to highlight a few of the tools that are available and share some links to relevant information at the end of this presentation. There are numerous reports and dashboards in LCS that can be used to monitor and troubleshoot performance. One built-in tool, the performance timer, while not to be used by the tester during the performance test, can be used to collect insights on slow interactions by a dedicated super user during the test or afterwards for analysis. The feedback form can be used to help identify a specific session for later analysis. And the query store collects amazing information that can be used to troubleshoot performance issues. Lastly, if there is a specific slow process that requires deeper analysis, users should collect traces so that they can be analyzed. I'd now like to hand over to Kenny, my colleague.
Thank you, Stephen. So now after manual testing, let's have a closer look at how we can automate testing using the PerfSDK SDK. So PerfSDK is a software development kit that helps you simulate concurrent user load and user activity. It's built on top of Visual Studio load testing features. And just to clarify one thing here, previously there was a DevOps cloud-based load testing service available, but this has been retired since March 2021. This service in DevOps was able to provision load testing agents on the fly for you based on the load testing configuration you specified. Although the service has been retired, Visual Studio 2019 still has the capabilities to configure and run load tests, although using a local controller and agent that targets a Dynamics Finance and Operations app instance. So to be able to edit load test configurations, it's also required to have the enterprise version of 2019. So if you deploy a tier 1 or a cloud hosted environment, make sure in the configuration settings of the deployment, you select the enterprise version of Visual Studio. To record user actions, we're actually using the task recorder to create the recordings, and by using the Finance and Operations app developer tooling, we can actually transform those recordings into C# tests. First, let's have a closer look at how PerfSDK is using the different testing infrastructure components. So when setting up load testing, you will actually typically use two environments for that. First environment on the left side, you'll see that we're using a tier 1 environment to host the PerfSDK components. And the second environment will be the actual target sandbox environments dealing with the actual user interactions requested by the agent and controller. So the tier 1, we are actually using a tier 1 environment mainly for two reasons. So first of all, because all the components are there and because Visual Studio is already pre-installed. And secondly, because you also have a local Dynamics instance in case you want to quickly test and debug something locally on that machine. The tier 1 machine also allows us to configure the load testing project in Visual Studio and also generate C# performance tests through the Dynamics add-in available on the machine. When running the load test, the tier 1 will actually have a local controller and agent created locally, and it'll start firing the requests towards the target sandbox environment. The sandbox is the target of these requests and is going to handle the actual user interactions we try to simulate. Authentication is done towards through certificates that can be downloaded from the Sandbox LCS environment page, similar to how it works for Regression Suite automation tool. Moving to the initial configuration part of PerfSDK, we start by leveraging a sample solution and project that is available on each of the deployed cloud-hosted environments. After opening the solution in Visual Studio, we are using the configuration steps that are also documented in more detail on Microsoft Docs to prepare our solution to run multi-user load testing scenarios. So one of the first steps is acquiring the certificates from LCS, enabling us to authenticate with the Sandbox target environment. And we do this by downloading the certificates from the Sandbox environment details page on LCS itself and installing them locally on your cloud-hosted environment. Second thing, so next is the cloud environment.config configuration file. That's actually the main configuration part, and that contains things like the URLs for the Sandbox endpoint we intend to target, your tenant and test user configuration, and the certificate thumbprints of the certificates we downloaded from LCS and we use for authentication. So once all that configuration has been done, you can actually run the test user creation executable that is also in the PerfSDK directory to create your test users in the finance and operations apps instance. This is actually a good practice because it uses the same configuration to connect to your instance. So it's already a good test to ensure that your configuration is correct. Once we have correctly done those configuration parts and have added some tests to the project using the developer tooling, we can start thinking about like how actual load testing scenario configuration looks like. And before we show that in a demo, let's go over some of the concepts that come into play when you compose a load test. So first off, we have a concept called a test mix. So a test mix is the definition of all the tests you want to include in your load test. And as a part of that, you can specify a percentage for each of the test scenarios in the overall distribution. Important here is to think about the realistic test mix that represents how users would actually use the system. Second is the network mix. So there's also features available that allow you to configure options in terms of the network mix. So you can simulate different types of network connections. So you're able to simulate LAN connections, WAN connections, even metered connections. Next up is the load pattern. Load pattern is a part of the configuration that determines how user load is added to your environment. You can step up the number of users gradually, so you can use it, or you can use a constant number of users directly from the beginning. We recommend to use a step to gradually ramp up the number of users, as it will always allow you a brief period of time where, as the users are ramping up, you're able to already monitor and see how the system is holding up. As the next part, we also have the concept of duration versus iteration-based testing. By controlling the use test iteration setting in your load test run settings, you can decide whether you're going to use duration-based load testing or iteration-based load testing. So for duration-based load testing, it simulates load for a specified duration, as opposed to iteration-based testing, where you can say the test is executed for a specific number of times. In our scenarios that we are going to show, we are using duration-based testing. On the left side, you can see the settings that are accompanying the duration-based testing, and the test iteration-based testing is on the right side. Lastly, we also have think times. Think times are specifically useful to simulate the time that it usually takes a normal user to think and act between two actions within the client. You can find some of the documentation as a reference here. As we are using task recordings to generate the C# tests, we cannot use the default think times that the Visual Studio tooling provides with PerfSDK. What we have done is we have a simple helper function that will be used to look at the run settings and to think whether or not think times need to be included. And we will use a simple function to randomly generate think times between the minimum and maximum value we specify in the app settings. So now that we've quickly discussed some of the configurations, let's actually have a look at a quick demo showcasing these specific configurations. Let's have a look at some of the configurations we've been discussing previously. So first, we open the sample solution available on each of the tier 1 machines that we deploy. On opening the solution, we can see the cloud environment.config configuration file, which is the main configuration file for PerfSDK. Once opened, we're gonna have to make some changes to this file to reflect the right settings to be used. So first off, we want to make sure that the URLs are actually pointing to the right sandbox that we want to use for performance testing. In this case, we're targeting one of our PerfLab sandboxes. So we make sure the host and host name are correct and in place here. So the next thing will be the certificate thumbprint that needs to be used. To get the thumbprint, we have to make our way to the certificates on this machine first. In the Trusted Root Certification Authorities, we have previously installed the certificates that we downloaded from LCS to be able to authenticate with the sandbox we are targeting. So that we did from the environment details page on LCS, where we just downloaded the certificates, loaded them up onto this machine, and then installed them in this store. So if we open it up, here we have the certificate thumbprint. So we just have to copy this thumbprint and remember that for to put it in the configuration file. So let's close this up, and then we can make sure this value here is the correct thumbprint that we need to use. So now we're actually pointing at the right environment and we have the right thumbprint in place to authenticate. Next up is the user format. So the tenant part should definitely be reflected, and it is also preceded by a placeholder. When you create test users, as described in our documentation on docs, this setting will be used to number the auto-generated test users. As a last detail, we have a configuration ID here for self-minting admin user. So there we need to make sure we put the username of the actual admin user of the environment so that is in place. Once done, you can save this file, and that's actually the main configuration that we have to do here for this file. Next, let's have a look at how we actually can define the load test and how we can specify the test mix we want to use in that load test. So we open up the load test file, and then a graphical editor shows up where you can actually configure all of your settings you want to do. So first off, we have the run settings and you have scenario settings. So those are the main two parts. First, when we look at the run settings, this is where you can specify the number of agents you want to use and where you can decide whether you use test iterations for your scenarios or if you use the duration-based approach. For the test iterations, it's just a number of iterations that you can specify. When you use the duration-based approach, you can specify the cooldown, the actual test run duration, and the interval for the sample rate in the graphical output of the test. A warm-up duration is also included. So that's for the settings itself, and then defining what you want to run happens into the scenario configuration. So in that, you have a test mix, a network mix, and a load pattern. For the test mix, you can edit it, and then you can decide what kind of coverage each of the tests that you have available has in the load test. So we have a distribution here, for example, where it says none of the tests will be one of the first two types. It'll only be creating purchase orders if we would run this test. So that's for the test mix. The network mix, that is actually enabling you to specify different type of connections. So if we want to add something else, like a metered connection, we can do it. Or like if we want to simulate a dial-up modem or anything we want, then we can specify that in the test here. For us, let's remove it again. And then the third important thing in the scenario configuration is the load pattern. There are three types of load patterns that we can configure. One is the constant load pattern. If we pick that one, then it means it's just a constant number of users during the duration of the test. If you go with a goal-based load setting, then it's actually based on one of the performance counters, but this is kind of useless to us because the performance counters will apply to this machine and not the actual sandbox we are targeting. So this we cannot use. The best way is actually to go with the third option, is with the step load pattern. This is because then you can gradually ramp up the users along the test, and then you can start out small. For example, let's put it in here, like we start with 1 user. Then the maximum user count, let's match it with what we had in the configuration, 10. And then step duration, 10 seconds. And then for each step, so each 10 seconds, I want to add 2 more users. This is how you can configure it. This is ideal to kind of monitor the system as the test is ramping up slowly and then up until the full potential. With that, we have checked all the settings we want to do to kind of configure the load test and start running the test. So next up, we have 2 scenarios prepared. So the first scenario, before we look into those scenarios, it is important to note that for each of the scenarios that you create or that are included in your performance testing, the customer agrees on the characteristics of the scenario. And they also need to acknowledge that this represents the realistic scenario and the realistic outcome. And then the way we think about how you should define the scenario is, for example, in this first scenario, we want to test the creation of purchase orders, for example. It is a simplified scenario for demo purposes, obviously, but for this scenario, we are simulating 15 users, for example, that are creating purchase orders simultaneously. So when you are composing the test, we keep the following considerations in mind: is that data composition, as we have stated before, is having a big impact on performance. And I always say, like, one purchase order with 50 lines is not similar to 50 purchase orders with 1 line when it comes to performance. Additionally, using the same values for all of the tests is going to result in SQL Server optimizing execution from caching and so on. So that's also not realistic. We want to be using, in this scenario, a variety of vendor accounts and items to work with. Each purchase order has an average of 1 to 4 purchase order lines, and we know that our items are evenly distributed across purchase order lines. So the customer also has an expectation that the system should be able to handle, for example, 15 users simultaneously creating purchase orders. From a business KPI point of view, the team working with the system needs to be able to create 150 orders in 30 minutes, for example. So in this scenario, to meet these requirements of the testing, then we are using a CSV file as a data source to provide vendor accounts and items to our test cases. So within the context of the C# test, you're also able to write your own custom code to read CSV files through various options like stream readers or link or entity framework. So any platform of your choice will do. The dataset is containing different vendors and accounts to use, as you can see. And we're also using a variety of items where different items are also used different storage dimensions behind them. So in this example, you can see that the vendors and items that we will be used during the order creation. And another thing in this scenario is that we will be using the data source attribute instead of reading from entity framework or any other option. We are going to use the data source attribute. And by using that attribute, you can actually add a data source to your test context variables. There is a limitation here where you can only add one data source attribute to the test method. So this is only suited for scenarios where you can put everything in one source file. If you're intending to use a more complex data source or more complex files or multiple files, you should be thinking about moving to custom C# code to read from different files. Ideally, this should be a framework you can reuse across multiple tests and not just single-use code that you write. So using the data access method enumeration, you can also specify whether the CSV that you use as a data source is read sequentially or read randomly. In our example, we'll use the random method, of course. The deployment item addition there is used to instruct deployment of the file to the testing agent when testing is started. So then it will deploy your CSV file right to where the agent is located at. In our example, we need to add the example code that you see there to the method structure to add the CSV file as a data source. And then to actually retrieve the rows and columns, you can use the lines of code you can see at the bottom, right? So there is a test context variable. And then as soon as you have a data source available in the test context, you can get the data rows and then move from there. Let's just have a look at the actual scenario within the Visual Studio client. Let's have a look at the first scenario where we are creating purchase orders. So after we have imported the recording using the developer tooling, then this is what gets generated. So we have a test class here that was generated. And the first thing that we notice here, or the first method of importance here, is the test setup method. This method is responsible for a number of things. So first of all, we get the variables that we have for the thing time. We get those from the app settings. The second thing we see is that we have a setup data method where we actually get some of the data to be used in the testing. So we prepare some item IDs and vendor IDs. Then the third thing happening in this test setup method is the initialization of the client itself. So that actually goes into the configuration file for the PerfSDK, and then depending on these settings, it actually initializes a client that connects to the right sandbox and whatnot. Important here is indeed to always make sure you have the right company selected, and then it actually opens the client. So that's it for the test setup method. If we have a look, before we have a look at the setup data method, I do want to point out one of the attributes we're using specifically for this scenario, and this is an attribute that goes around the actual test method. The attribute I'm referring to is the data source attribute. So in our scenario, we want to be using a CSV file to get the item IDs and the vendor numbers. So that is what we can do with this attribute. So we specify what CSV file, where to find it, and we also can mention the data access method. So in this case, we are choosing for a random access method. So basically, all of the records within the CSV will be randomly accessed while running this test. So now that we have that in place, we know where the data is coming from. So now we can see the setup data method. This setup data method does a number of things for us. So first off, what it does is we kind of randomize between 1 and 4 lines as stated in the scenario description. So we get a number of lines that we want to add to the purchase order. Then secondly, we are actually getting the order account for the purchase order. The way we do that is if you have specified a data source, then within the test context, there will be a data row available. And then by passing in the index of the column you want to use, it is actually going to put the randomly selected data row in and then pick the value from the column we are choosing. So what we are doing here is the first value is obviously the vendor account. And then for the item IDs to use on the lines that we put in, then it's going to look for the other columns to get different item IDs in place. So that is what we do in the setup data method. Apart from that, the rest of the method is actually the rest of the class is actually the method that actually does the creation of the purchase orders. For this, we kind of leave much of the code that was generated in place, but what we do is mainly inserting some think time at places. We use those variables we have in the configuration settings. And the second thing we do is we time a number of things using a timer. PerfSDK will already by default for each of the actions and the attachments it does will already put a timer in place. But what we do is we kind of give, we put in some timers that are named so that we can specify bigger chunks that we want to see. So in this case, what we are doing is we want to see, for example, a timing for the creation of the purchase order header. And then we end the same timer after that is done. And then you'll see there's a number of timers in here for the first purchase order line, second purchase order line, if there is any. So that's what we have done here. So basically the same code that is generated by the add-in, just with some additions that we do. And then one more specific to this method is we use the randomized number of lines that we got initially. So here we decide, okay, what's the number of lines we want to add? And then if there's more than 1, 2, 3 lines that we want to add, we just copy pasted the same piece of user interaction. And we're executing that multiple times. So with that, that's what the create purchase order method actually does for us.
In the second scenario, we have a customer who uses a third-party POS. Each night, a middleware application runs that consolidates the transactions into individual sales orders then emerged into one file that is imported into Dynamics 365 Supply Chain Management. The peak volume is 200 sales orders per night. Each morning, a team of 10 people log into Dynamics, open the sales orders, and then invoice them by submitting them to batch. Their KPI is to complete this activity in 1 hour. We understand that in most situations, a customer would have a process to automatically invoice the sales orders. However, we wanted to use a straightforward scenario so that we could focus on the main points, specifically how a database can be used to store parameters and how records can be filtered. The way we are using the database represents one approach. As such, if your requirements are different, you may want to achieve the same results using a different method. As you're aware, you can set up Visual Studio on separate machines, which may or may not have SQL installed. So while we've chosen to use a cloud-hosted environment for demo purposes, it is likely that customers and partners would want to use multiple VMs, which wouldn't all be pre-configured with Dynamics 365 apps. In those cases, you could install, for example, SQL Express. However, as the cloud-hosted environment comes with a developer version of SQL, we're using that. For this scenario, we have created a simple database to use. It has 2 columns, sales order ID to store the value of the sales order we want to use and has been used, which is used to determine if the sales order has already been processed or not. 0 indicates it hasn't been used and 1 indicates that it has been. For our scenario, We also put a clustered index on sales order ID and a non-clustered on has been used, mainly to reduce the chance of the query going into a page or table lock, because then there is a chance that the threads would skip the pages or table, returning nothing, or end up becoming a bottleneck itself. We also made sure that the database does not have read committed snapshot enabled. Looking at the query we wrote to retrieve the sales order ID, we use a common table expression to select and update the record, which should prevent other threads from selecting the same record at the same time. Simply put, this query is selecting the next sales order ID from the list where has been used is set to 0, and then updating has been used to 1 and returning the sales order ID. A couple of other factors to mention are, in this scenario, we're using read past hint. Also, the query is going to be executed with an isolation level of read committed. Using this approach to query the database is, as I mentioned, only just one example. There are usually many ways to meet a business requirement, so it's important to understand what those requirements are and use the appropriate method. I wanted to mention that we're using the app config file to store the connection string to the database, as well as other parameter values, for example, those used for think time. When recording the scenario for PerfSDK, we use the filter to select the sales order we were interested in invoicing. The task recorder created the necessary code to enable this. So we substituted the hard-coded sales order ID with the sales ID that we retrieved from the database. There are other options, such as calling apply filter directly. However, you should evaluate the best option for your scenario and requirements. For example, the JSON notation offers greater flexibility around filtering options. So we're just going to look through the changes that were made to the multi-user C# code in order to leverage these features. Here you can see in the test setup method that we have used the settings in the app config to configure the connection string as well as the think time values that we will be using throughout this demonstration. One thing to point out is always remember to change the company that you want to refer to or leverage for the data set. And here we can quickly look at the insert think time method. It's relatively straightforward and uses random num function in order to select a random think time. Here you can see the sales ID statement that we've examined in more detail previously, and it's going to be used within the fetch data method. This fetch data method uses the connection string that we defined earlier and also uses a transaction isolation level of read committed. So fetch data itself executes this particular SQL statement that we've defined, and it reads in the sales ID, which it then will return. And what we want to look at now is the setup data. So in this method, we're reaching out and calling fetch data in order to retrieve that sales ID as we discussed. And then we have updated the filter parameters in order to leverage the sales ID so that the system will find the sales order that we are looking to invoice. And then there aren't many more changes to the actual test method that was created via the task recording. We are, validating again that we have found a sales order ID just to ensure it's going to have a sales order to process. And then we are inserting again that user think time to simulate a user pausing or moving the mouse before clicking or taking that next action. And then you'll notice that throughout it, we've added these test context begin timer and end timer statements, just so that, again, PerfSDK will record various timings, but if you want any custom ones, you can use this begin timer, end timer in order to specify the specific timings you're on after. And that's fundamentally the changes that we've made to the C# code that was created from the task recording and converted to the multi-user test. So thank you very much. And with that, I will hand back to Kenny to take us through how he can generate the reports.
Thank you, Stephen. So when you've executed the load test by just running the code that we have just shown you, then you can actually generate the load test result reports. So this is available from either the test results window or so just within Visual Studio where you start the test, or you can use the load test add-in available in Excel to do that actually. So there's two types of reports that can be generated. First is a run comparison report. The second type of report is a trend report. So the difference between those two is mainly that the run comparison report does what it actually states, is that it takes two specific runs and it compares those two specific runs with each other. In that report, you'll find that one of the runs will be treated as a baseline result, and it'll show you the progress or the improvements compared to that baseline. That's how that type of report works. The second report is the trend report, and that actually allows you to monitor a trend across multiple series of load test runs. So it's similar when you started out in Excel and then you say create trend report, and then it'll allow you to just select multiple runs together, and then we'll draw you that result. So there is some of our LCS deployed cloud hosted environment might present you with a challenge with the Excel add-in for generating the reports. It'll actually prevent you from connecting to the test results, and you will be unable to open those reports for it. But knowing that Visual Studio 2019 is using local DB instance to store the test results in a database there. So for you to be able to generate a report or be able to use Excel to connect to those test results database, you can actually extract it from the tier 1 machine by just connecting using the Visual Studio tooling to the local DB instance, and you can extract it to a DACPAC file. You then just move over the DACPAC file to any machine you want to use containing VS 2019, Excel and the load testing components, and then you will be able to open Excel and use that. So you can read in the DACPAC file and then restore the actual local DB database on that machine. So and then using the same tooling, you can then connect Excel directly to that database, and then when you say next, then it'll immediately read all the test results and then let you select the reports to generate the testing runs to actually generate the reports. So that's how you actually can still generate the test result reports. To close off, I would like to loop over a few of the best practices that we see across customers. So first of all, always start your recording from the main dashboard. Why is this? Because if you mix up different tests, if the test doesn't start with the main dashboard and does not go through the menu options to open a specific menu item from the main menu, then your test cannot assume that you're on the main dashboard, and then you would end up somewhere where you don't want to be. Also, run through the expected scenario prior to capturing it. Why is this? Just to ensure that what you have recorded, just loop through it again and use it in a browser or in the test recorder, and then let it run and play all the steps without you having to touch it, right? Then you get already a good indication if the recording is correct. This is what I call it's garbage in, garbage out. If there's something wrong with the recording, you can spend a lot of time trying to debug things where it's actually the recording that is wrong. When recording the scenarios, also avoid using drop-downs or lookups. If you can, enter the values by using the keyboard. That's a preferred option to do so. Also ensure that you are not inadvertently using someone else's personalizations that might affect the test. So we are generating test users. You need to make sure that while you are recording using the task recorder, you are not recording with a user or a persona that actually has the that has like personalizations or a different, or did not execute the or open the form yet, so that the visual state of the form looks different than the user you are going to use. That's a pretty important one. Make a backup of the cloud environment config file. That goes without saying before you convert some of the tests. During the test, you can also set specific timers as we explained in the scenario. So pass in the name to distinguish the test from others. Make sure that you use the same naming, because otherwise aggregation will result completely wrongly in the report. When possible, use enum values in your C# code and not actual values, as those might change or some other values might change between the environments. Then also, if you are debugging a multi-user test, I would recommend you to set the constant user count in the settings of the test to 1. Why is this? Because otherwise, different threads will run in parallel and they will all hit your breakpoint, and it will be difficult to figure out which thread am I debugging here. Load testing environment should have production-like customizations, configuration, sample data. So environments that are not configured as close to production as possible will not have the same results as your go live. So you might be surprised there. So use a pool of test users for manual performance testing. So there, what we mean by that is for manual performance testing, you configure test users to execute tests based on a certain security role. So you can include that. Including security roles will result in more accurate results for performance, as different security configuration most likely can have a performance impact, especially if you're using things like XDS policies. If you run that as a system administrator, the XDS policy will be completely ignored even. So you need to test with appropriate security. Use Azure VMs to host a test that are closest to the actual environment you want to test, right? So that don't end up in 2 different regions that are far from each other. That might be causing an impact in terms of latency for the web requests. Also, don't forget to monitor machines that the tests are being run on. So what you're doing, your tier 1 will host the agent. So any performance counters on that machine are useless to you, because you are executing tests towards the target environment. So you'll have to use the typical tooling to understand the stress on the environment that you are targeting, hence the sandbox. And lastly, be realistic. Load testing is not stress testing. What we're intending by that is that stress testing is where you want to stress the environment up to a point where you say, okay, this is, I want to see where it's going to fail. Load testing is where you say, okay, this is the load we estimate to have on a real life or in a day in a life. So let us test against those values, and not necessarily say, hey, I want to test how if I can post 100,000 invoices in an hour if you only require to do 1,000, right? So be realistic in the test, in the KPIs that you want to achieve. Lastly, we did include one slide with a few of the resources, so you will be able to go and look at those resources. And with that, we've ended up at the Q&A section. So thank you for your attention, and I'll be handing it over back to David.
All right. Well, thank you, Kenny, and thank you, Stephen, as well, for a great presentation. I've posted a link to a short survey in the Q&A panel. We'd like your feedback on today's session and hear what you'd like to see in future events. Thank you for your participation. As a reminder, the recording of today's session will be available on the TechTalk's Community Dynamics page within 5 business days. I'd like to extend a big thank you to our presenters and audience for joining us today.